Hello, welcome to This Week. I'm Craig. Let's talk about fuel cells. So, we've talked about a lot in this class, right? We've gone all the way back to kind of the basics of the ICE, and then we kind of talked about emissions, CAFE standards. You got EPA compliancy and some kind of these, the basic emission requirements for the next several years and how we're going to meet those standards. And a big part of this class was hybrids, electric vehicles, compressed natural gas, and now fuel cell. But we talked about safety, right? How do we work on high voltage vehicles? How do we work on high pressure gaseous fueled vehicles? How do we safely deactivate, depressurize these systems to remove components, replace components, and diagnose components? So I kind of want to go over a little bit about fuel cell. Not a whole lot. There's still a brand new technology. Depending on what part of the country you live, you may or may not see these. Of course, metropolitan areas, Sacramento, LA, San Francisco, you're going to see these vehicles right out of the bat. But you will probably not be working on them right out of the bat. It's going to be more than likely a journeyman technician who's been through several trainings. So, but to give you an idea of what's going on, these vehicles use hydrogen, okay, but they use it in a unique way through a fuel cell. We're not going to use hydrogen in a combustible engine like we have in the past, or some DIYers on the weekend used. They used electrolysis to separate hydrogen from water and oxygen, and then they ignite it. They add it to the airstream of the gasoline internal combustion engine, and then they ignite it. It's pretty barbaric. What we're talking about here is more of a scientific process through a catalyst and the hydrogen. So basically, by definition, a fuel cell is a device that produces electricity by separating the protons and electrons in a hydrogen molecule. The protons and electrons are reunited on the other side where they combine with oxygen from the environment to create water. In layman's terms, we use hydrogen and we split it and we run the electron because a hydrogen atom has one proton and that one electron. And as we separate that electron and we move it through a circuit, we're going to use it to power an electric motor. When we combine it to the other side, you see over here on this cathode, when oxygen from the atmospheric air comes in and contacts this plate and it meets up with the electron and the proton, the byproduct is heat and water. So the byproduct is basically, like I said, water and heat. It's pretty clean. So cool system. But how is this useful? So like I mentioned earlier, instead of using this homemade DIY electrolysis setup, this is pretty fancy. You hear a lot of current going through here, and the battery. This would separate the hydrogen and the oxygen out of the water because water is H2O. We separate that, and then it runs. Looks like this little doohickey right here, tube into the intake, and then that's going to offset your fuel trims using less gasoline in the vehicle and more current from the alternator. But what this allows you to do, again, is save fuel. These were popular in 2008 in that recession when gas prices were close to $5 a gallon. The alternative is on a hydrogen fuel cell, we use these stacked plates, and it does what I mentioned before, is we take the air from the atmosphere and we take hydrogen, combine them on either side of the anode and cathode, and that's going to influence and through that catalyst propel that nucleus with the proton through the center, that PEM, and that's going to separate the electron. It goes through the electric motor. Basically, the hydrogen fuel cell vehicle is an electric car. It's just that we're using hydrogen to create electricity instead of electricity stored in the battery. They still have batteries, they still have electric motors, but instead of plugging into the grid and charging, like off photovoltaic cells, it's going to use hydrogen in a pressurized tank, and then that's going to go through a hydrogen fuel cell to create electricity to either charge a battery and or operate that motor, electric motor. So much more efficient use of this energy, also much more complex. So where do we get this hydrogen from? Well, hydrogen being the most abundant element in the universe, not that hard to find, but it is pretty hard to find by itself. It's a pernicious molecule. It bonds easily with most elements, making it difficult to separate. So right here we have water, H2O, and here's methane, 4 H's and a C right here. So we have hydrogen's available. How do we separate that? That becomes a problem. There's a couple different ways we do that. They all have pros and cons, but we have steam reformation, electrolysis, biomass gasification, and coal gasification. So electrolysis being very popular, but also inefficient, where you run current through like water and it separates that hydrogen, oxygen from the H2O. Steam reformation is a more popular, affordable version where we can remove that hydrogen out of like basically manure for the most part. There's biomass gasification, which isn't as popular. YouTube that. It's complex and expensive. Coal gasification again, but steam reformation is probably by far what we see mostly, at least that I know of at this time. So again, electrolysis using this method, at the time of my research, 4,000 kilowatts of energy to create 1,000 kilowatts of hydrogen energy. So obviously we're losing energy. So why would you do that? Well, we're not really using hydrogen to create hydrogen or gasoline to create hydrogen. If we're using a renewable energy source like wind or solar through photovoltaic cells, like a solar panel, then one can say that once you purchase the equipment, the loss of energy is negligible, or not an issue. It's not a problem, because you're still creating energy out of almost what would have been wasted as zero energy, I guess some view at that point. Although obviously you have the argument it takes energy to create that product for initial installation. So there's graphs and charts. You can go into that. I'm not going to go into that too much, but do know electrolysis is power hungry. So not a huge following on there. But we can use geothermal, we can use wind, we can use solar, we can use all kinds of different ways to create energy to separate the hydrogen from other basically molecules. So we have wind power, solar panel, geothermal, tidal current. None of this is real popular. Solar probably being the number one front runner on all this. Geothermal's got interest, but very costly. Tidal current and wind power, you have some environmental issues with that. But again, there's no perfect answer, I guess, is what I'm getting at. There are many ways to create energy to create hydrogen, but what's interesting is don't think of hydrogen as an energy source. It's more of an energy carrier. We're going to transfer energy to something that's transportable, like hydrogen. We pressurize it in a gas into a tank, a cylinder, or on the car, and we can transport the vehicle. So it's kind of more of an energy carrier than an energy source. Okay. Here's one of those tanks. We either have it pressurized right here, very similar to the compressed natural gas that you looked at last lesson. The tanks are very similar. They're inspected the same. A lot of the same products with a pressure relief device and solenoids, shutoff valves, etc. We also have cryogenic tanks, which aren't that popular because they're quite expensive and complex. But you can hold a lot more hydrogen when you lower the temperature to negative 414 degrees Fahrenheit. But again, that takes energy to lower it to that, but it is dense. Pack more in there. So as far as fuel cells go, there are different types of fuel cells. We're going to focus on the PEM because it's chosen by automotive industry, because of its operating parameters and its cost. So proton exchange member, alkaline fuel cell, phosphoric acid fuel cell, solid oxide fuel cell. Again, the PEM, the proton exchange member, is what we're going to focus on. So how does this work? We basically have four working parts. The proton exchange membrane, that's its name, right, the PEM. A thin membrane that only allows protons to pass through, so not electrons. We have an anode, a negatively charged electrode. We have a cathode, a positively charged electrode, and a catalyst, a thin coating between the PEM and the electrode. So between these electrodes and that PEM, we have a catalyst, usually platinum. And this comes into place here. So we look at this picture. If I run pressurized hydrogen out of that tank along this anode, and we have this catalyst, this catalyst on either side of this electrode right here, in my word straight, basically what's going to happen is as it comes across right here, and I have on this side oxygen on this cathode and this catalyst, through the reaction, the catalyst reaction, and the fact that we have hydrogen and oxygen here in this PEM unit, and we're inviting, enticing these electrons to flow through the circuit over here, the nucleus goes across, or the proton goes across this, that basically becomes this hydrogen ion, goes across this PEM, and it gets reunited with the electron on the other side, where it's bonded with oxygen to create water. So you have hydrogen, oxygen, water. Pretty cool. We capitalize on this process by forcing the electrons to go through, well, in this picture, a light bulb, but in the fuel cell vehicle, it goes through the electric motor. So pretty cool process. And to make it more efficient, the hydrogen is pressurized to get to this plate easier. And then the oxygen side, they actually run a supercharger, an electric supercharger, to pressurize atmospheric air through this area to run as much oxygen to this plate as possible. Because as you know, there's only about 20% oxygen in the atmosphere. So we want to run as much through there as possible. And then the byproduct is just this water and heat. Pretty cool. So that's kind of what this all says. I put this PDF on Canvas if you want to check it out. But that's kind of basically what we have in layman's terms. So here's the overview. You have your fuel cell stack, hydrogen tank. Here's that look familiar right there? Yep, little disconnect switch, a pure electric motor, an inverter. So a lot of the stuff that you learned on the Prius with the hybrids and electric vehicles blends over to this, right? Quite easily, actually. Because the technology for the electric portion of this, it is an electric car, it's just powered by hydrogen, where the electric vehicle gets its power from grid, and the hybrid gets its power from gasoline. So it's kind of just, but the technologies are very similar. Once you learn one, you learn most of them, how they work. That's why I'm really big into theory and operation and physics, because as technology changes, I was able to easily adapt in the industry and work on the next newest, latest, and greatest, because I worried more about physics and theory. So again, here's your exchange or your fuel cell stack, and then one of several hydrogen tanks on this vehicle. So a couple advantages, they are produce no emissions. Hear me out. Okay, it depends on how you sustain or how you gather your hydrogen, but the vehicle itself has no tailpipe emissions. Foreign oil dependence reduction, because we're not using gasoline. Higher fuel efficiency, which is true because the electric motor has a higher efficiency for propulsion, right? Much closer to 70 to 80% versus 30 to 40% of an internal combustion engine. So no negative environmental impact in case of a spill. If that hydrogen leaks, it just goes off the atmosphere. Hydrogen's everywhere, it bonds, and it's going to create basically water. So there's not a whole lot of environmental problem if it leaks, right? And hydrogen's actually more stable than you'd think. So it is explosive, it is dangerous. Don't mistake my word stable for safe. It's not safe, but it's not as dangerous as you may think. Its explosive range is minimal in parts per million. It is dangerous, like I said, don't get me wrong, but it's not like you're driving around in just a bomb. These tanks are very well regulated, very well tested, very in heat and temperatures and pressures, so they are very safe. Intrinsically safe. Anyway, but as far as saving fuel or saving cost, I don't know, not so much. You're going to get the equivalent of the 66 miles per gallon, and if you remember, the equivalent is trying to figure out how much equivalent energy is used as far as in terms of gallons of gasoline equivalent. So basically refueled in 5 minutes, so people are more familiar with that versus electric vehicle, which can take hours, as we learned a couple weeks ago. And it can drive 300 miles in a tank, so 30 to 50 bucks to fill up at today's cost. And that gives you 5 kilograms of hydrogen. It can be fueled in 5 minutes. You're not waiting around. So basically, it satisfies those that want to remain the same as far as infrastructure, right? Pull into a gas station, get fuel, take off. But it also satisfies environmentalists because it's better for the environment, and those who want to retain national security to lower our dependence on foreign oil. So a lot of people like this. It also helps the industry make money. Because, as you know, the automobile industry makes money repairing cars. These are more complex than an electric vehicle. There's more work to be done. So you still can have the service industry making money. So it actually satisfies and checks a lot of boxes. So a lot of people like this technology. Whether or not it takes off, time will tell. But it looks promising. Some things to worry about, but they are changing infrastructure. When's the last time you saw a hydrogen fueling station? Yeah, I didn't think so. But it's out there. We hydrogenate a lot of our foods, so hydrogen is an abundance element. Costs more energy to produce and gain. We talked about that. The platinum catalyst in the fuel cell is expensive, around $30K for a new fuel cell. So the new Toyota Mirai basically is a really expensive $50-some thousand Prius or Camry. I guess you want to look at it that way. A Corolla, probably more of a Corolla, yeah. So Toyota, Honda are firm believers in this. Toyota has a Mirai, Honda has a Clarity for fuel cell. They see this as being a means to power your homes too. So if we can produce hydrogen at home, you can power your house off a tank in your car for a week, as depicted by this picture. The trunk of the Mirai has a CHAdeMO plug, like we talked about a few weeks ago, that you can plug into your house and actually use it as a backup generator instead of using a generator in your house that runs off propane, diesel, or gasoline, or having solar panels and batteries. You can just plug in your car when you lose power. So pretty cool. I like that. I actually like the hydrogen fuel cell vehicles, but I don't know. Again, they have their flaws. Well, time will tell if this takes off. But it has 2 systems to maintain, so that is a negativity. But it has a lot of positive characteristics. So again, time will tell. But that is introduction. You will find some more videos on how this process works below. If you have any questions, email me. Thanks for watching.